Hi class, welcome to another lecture on CS575. This time we will be seeing how to remove non-stationarity and make the data stationary. So why do we need to make the data stationary? Because we have the models AR, MA, ARIMA and all. Those are linear models and can only be applied for stationary data series. So the non-stationary pattern in the time series data needs to be removed in order that other correlation structure present in the time series can be seen before proceeding with model building. Again, since we are dealing with the Box-Jenkins model, we are on the identification phase, estimated and testing, and application. These are the main three steps for the Box-Jenkins models. So one of the way of removing non-stationarity is through method of differencing. So one of the most simplest and widely used method is differencing. So removing non-stationarity in the time series is like the differenced series is defined as y dash t is yt minus yt minus 1, right? So you have a series, you take the lagged version of the series and then subtract to obtain a new series. If you remember in our previous class, let us do this thing. We have a lag of 1, right? So we have the original series here, right? So let me make this as the original series. This is my new series. This is a lagged version, right? It is a lag of 1, and now I just say the difference. So let me just keep the difference here. Now if I make this as like this minus the lagged version. So now you can see anyways the last value needs to be ignored. If I plot this particular series, scatter, right, it again has a pattern here, right? So then we can take basically the second order difference also. So we take that difference till we basically get a stationary series. We will see in this particular example. The following two slides shows the time series plot and the ACF plot of the monthly S&P composite index from 1979 to this. So you can see here basically there is a trend here, right? You do not have a constant mean, right? Because if I plot this particular line, you can see the mean is increasing as we move further. So now what they do, they first calculate the ACF. So you can again see we have a large number of ACFs which are above 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, almost 17. Till 17 lakhs, they have coefficients which are above the interval level, and then there is also a decaying thing, right? So which are slowly reducing things, so both the conditions are satisfied, and after this again the partial autocorrelation for a value of 1 is close to 1 and all other are basically close to 0. So this shows that the data is non-stationary. Again, the time plot shows that it is non-stationary, right? And ACF and PCF, as we have already seen, it displays a pattern typical of non-stationary pattern. Now we are taking the first difference. So what happens on the first difference? We get a series like this. Now you can see if I make a straight line like this, so roughly you can see the mean stays constant, right? Mean is around constant. Not a very strictly stationary time series, but at least now the increasing trend is disappearing, right? So now you can check the autocorrelation of this differencing time series. So basically this is the first difference, right? As I executed in Excel, this is the first time difference, right? So now you can see only for lag 1 it is above this 95% interval, and then rest of these are below the 95% interval, right? So a majority of them are basically within this. So this will correspond to a white noise model. Again, for PACF also only one lag is above this particular interval, and it says an important point. Note that the ACF and PCF at lag 1, right, is outside the limits, right? Because we in a white noise ideal model we want all this to be within this. But it is acceptable to have about 5% of spikes fall a short distance beyond the limit due to chance. So we are allowing 5% of the spikes fall a short distance, right? So you can see this was the limit. This distance is a very short distance, right? That falls beyond the limit. So we treat this series at this particular point as stationary. If you want, actually you can take the second difference also, right? Then removing non-stationarity in time series, the time series plot and the ACF and PCF plot indicate that the first difference has removed the growth in the time series. Now why does it says growth? Because if you see the original data, basically this was the growth, right? If you can see, there is, these values are roughly less than 200, then we have a growth here, we are reaching almost 400. So this was the growth. So once you took the first difference, the growth basically is removed. Now you can see the value growth is not as significant as we saw in the previous case. The series just looks like a white noise with almost no autocorrelation or partial autocorrelation in the 90 outside the 95% limit. Right? We had only just one value, and we are taking it as a as we saw in the previous case. It is acceptable to have about 5% of the spikes, right? So we can just treat it as a method for removing the non-stationarity. So that's it guys for this lecture. I hope you understood the concept. So we see more details about this